A similar figure is something that is the same size, same shape, but a different size. So like a picture. No, we just went over why that's a bad idea. A picture of yourself. You are not that size, but it's still an accurate representation of you. So if you take a picture on your cell phone, what you're seeing has been shrunk down to fit on your screen. It's still the same stuff. Like if you're taller than your neighbor, you're still taller than your neighbor, but now you've shrunk down and you're on a tiny screen. That's a similar figure. All right. There's another word we're going to work on that's used called corresponding. We're going to use this a couple times. When they call something corresponding, it's like they're talking about their partner piece. So if I take a picture, I'm going to cover it up real quick. So this is a picture. And so this is my husband. This is still my husband. Those are corresponding pieces. It's the same piece, just in the other picture. This is Max. This is still Max. Same dog, just in the other picture. So I just called it's matching partner. It's the same side, but on the other shape. There are two laws. I shouldn't even call them rules because you can break a rule. But the two laws of similar figures. One, and you have to follow both of them or else it's not. The first one is that corresponding sides must be proportionate. Are proportionate. And remember that when we talk about proportional relationships, we're talking about multiplying and dividing, not adding and subtracting. Not adding and subtracting. If you add if you have a picture frame and you add 2 inches to both sides, that might not be the same proportions anymore. If you have like a 2x3 and you add 2 to one side and you add 2 to the other, a 2x3 is not the same as a 4x5 because you doubled the length, or you doubled that 2 to a 4, but you didn't double the 3. You just added 2. So it doesn't work. Don't add. Even when it feels really like, oh, they just added 1 to every side. No, doesn't work. And then the other law is that corresponding angles are equal. Absolutely equal, have to be the same. Which is really easy with a rectangle. I'm going to cover it up again. These are rectangles. It's all 90 degrees. But the sides are what I would have to check here. So you have to check both. Because even though all of these are 90 degrees, this is definitely not a good representation of this picture. All right, I'm going to draw 2 triangles. I'm going to try and make them as proportionate as I can. There's one. And I'm going to try and flip it over and turn it around. So this is the short side. This is the longer side, and this one goes that way. Now, when we draw shapes, when we label shapes, we give them letters on their vertices. A vertex is a vertex. This is not a point. It's not a corner. It's a vertex. So this is going to be triangle A, B, C. And then over here, I'm going to name this one X, Y, Z. So we have A, B, C, X, Y, Z. And when I talk about these triangles, you draw a triangle. So that's triangle, A, B, C. When you write your triangle, you generally go alphabetical and you follow the line. So you go A, B, C. And so if this one is A, B, C, this triangle would be X, Y, Z. Triangle A, B, C, and triangle X, Y, and Z. All right, and the symbol for similar is an equal sign with an S on the top. Which means they're the same shape with similar qualities. I don't know if there's an easy way for you to remember that. Yes.
What do you mean same shape and similar qualities?
They're both triangles, and I'll get there. Because the numbers I'm going to use aren't obvious. So, but like if this one was half the size of this one, so if this side was 10, then this side would be 5. So that's the similar part, the proportional similar, all that. Cool thing about similar figures is the letters give away the answers sometimes. So letter A goes with X. Those are buddies. So I'm going to put a 1 swoop in A and a 1 swoop in X to help me know those two angles are buddies. They're corresponding angles. Angle B gets 2 swoops, 2 lines. So angle B goes with which angle? Y. So Y gets 2 swoops. So I know that they are corresponding angles. And then C, we're going to give C 3 swoops. And what is C's corresponding angle? C. Good. Now these symbols in the angles show me which ones are equal. So if it's got 3 swoops, it's equal to the other 3 swoops. If it has 1 swoop, it's equal to the other 1 swoop. And then when we talk about line segments, we generally go alphabetical. So if I wanted to say line AB, which is this one, AB, is similar to which line over here? XY, yeah. So if it's AB, the first two, it goes with XY, the first two. So this one, which is 6 long, goes with this one over here, which is 5 long. And then BC is 9, and it goes with, which line does BC go with? YZ. So YZ is over here, and it is 7.5. And then last one is AC. So you've got your first letter and your last letter. it's 12. And so first letter over here is X, and the last letter is, so this is that line that goes with it, and it is 10. Now, the relationship between these numbers is not obvious. We have 9 and 7.5, 12 and 10, and 6 and 5. Some of you are going to say, oh, you just blah, blah, blah. Yes, okay. Sometimes people don't see the relationship you do. Okay? So, here's how we check similarity. Your whole task today is to test whether these two things are similar. So, you are going to pick a side and its corresponding side. And write as a ratio. So on triangle ABC, which side do you want to use? 6, 9, or 12? 9, okay. What is 9's corresponding piece on XYZ? 7.5. So I'm going to put 9 over 7.5. Oh, thank you. It does not matter which one goes on top. But since I picked a 9 from the big triangle first, my relationship here is big triangle over little triangle. So pick another number besides 9. Okay? And then what is 12's corresponding angle from over here? All right, so you're going to repeat. Your second step is to repeat with a new side. Now I have two ratios. I need to know, are they equal? We can test if they're equal by cross multiplying. Is there another way we could test if they're equal? How can you test if this fraction is equal to this fraction? You could. Most people don't want to, but you can. You could change this to a decimal by dividing, and you can change this one to a decimal by dividing. But what we're going to do with this tomorrow, you probably don't want to do it that way, but you could. Because all I want to know is, are these equal? So 9 times 10 is 90. 7.5 times 12. What's 7 times 12? 84. And what's half of 12? So what's 84 plus 6? 90. So are they equal?
Yeah.
So if they are equal, they are similar. Rules for your proportion. You have to pick a pattern and stick to it. So if you compared big triangle to little triangle, it's got to be big triangle over little triangle. Big triangle over little triangle. If you did pink over blue, on the other side you have to do pink over blue. You could do green over pink, as long as you do green over pink. You have to pick a pattern and stick to it. And then you can set these up a lot of different ways, like 8, I think, at least 8 different ways.